Alright, I wanted to get a short video out to y'all explaining the concept of function as we're going to be thinking about it initially here in pre-calc. That's the main thing we think about in pre-calc is functions and the graphs of functions, and we'll look at particular types or categories of functions as we go along. But functions to begin with, we're going to think about two kinds initially, and that's functions where the input is distinct objects. And I'll have a couple examples on each of these, but could be numbers or letters or words or whatever going into it, but we're just considering them one by one, the inputs. And the other type is where the input is portions of the real number line. So what you're used to dealing with is with functions in algebra and trigonometry is the input is a numerical input, and you can change it a little bit. You know, it's like an input variable x that can go up and down and within some part of the real number line, maybe the whole real number line. That's the typical kind of function we're thinking of. We want to get comfortable with both of these. We're going to look at a couple examples of each. But part of it, I'm going to put a question mark there because part of what we're thinking about is this thing really a function? There is stuff where the input is in these categories that might not actually be a function. We want to think about that rule. The rule for a function of whether each input has exactly one output. Each input that's in the domain has exactly one output. That's what we have to worry about with these to see whether or not it is a function. So for the ones with distinct objects, I have a couple examples written out here. You might see these with just arrow diagrams because these are distinct objects over here. They happen to be numbers. But we're not talking about a number line thing where there's values between 1 and 2. Not with this. We're just talking about these particular values, and that's it. 1, 2, 3, 4, or 5. Written out here, and if you can see what's going on with the arrows, I only did the first few there. I'm going to finish this off with what the arrows are on this. But 4 goes to O and U, and 5 goes to I and goes to E. So if you haven't picked up on the rule on this thing, what I'm doing is putting an arrow if that letter is contained in this word. This is my set of vowels over here, and 1 contains the vowels O and E, so I have arrows going to O and E. So the input is the word, and the output is any vowel that's contained in that word. And so you have a relation there, but it's not a function because the rule for a function says each input has to have, that's in the domain, has to have exactly one output, and 1 here has of course O and E both in it, so we don't have an f of 1 because it goes two different places, and that's not good. That also happens down here with some other ones, but if any of these have more than one output, then it's not a function. So this one's not a function. There's a rule there, but it's not a function rule. Here's a different word, different one, where the input is the word. And we could actually use any word in the dictionary on this. The output is the number of letters in the word. So if we call this function f, the f of notation that you're probably used to from math is you put the input inside here. Whatever's inside that parentheses is an input. In this case, it would be a word. And if I put the word marker in here, f of marker would be the number 6. It's the number of letters in the word. So f of spoon is 5. I'm just looking at what's around. But I could use any word in the dictionary. This is going to have number of letters in the word. So these will be counting numbers over here, or natural numbers. But each input will have exactly one output because there's no way f of marker could be anything else, right? Each individual input that's in the domain is going to have exactly one output, the number of letters in the word. And so that works okay as a function. This one is a function. We can ask a little bit more about these, but I want to look at a couple in the other category quickly where the input is real numbers or portions of the real number line. So this one I wrote out in words what the rule is for it. The square root of 1 minus the square of the number, where the input's the input's a real number on this. That's kind of confusing to write it out that way, and it's not quite clear what the order of operations is. That's why we're glad that we have algebraic notation for this thing, because if I just give this a name, typically x is the input variable, then I can write this as the square root of 1 minus the square of the number. It would just look like that. And to say that's the output of the function is to say f of x equals square root of 1 minus x squared. That's the algebraic way to write it. That's the equation of the function, or the formula there. And that's a function. Any number that you put in there, you do these calculations, and you're not getting more than one thing out of it. If you can write a nice formula like that, you're going to get the result of that is the output that goes with that input. So this is a function. But we're going to have problems with certain numbers there, and we have to think about what that is, what exactly is the domain of that. I'm going to come back to that. Another way of looking at these, since our input is a portion of the number line, we can look at the graph of the function using the traditional xy plane. So this is the inputs along the x-axis normally, and this is the outputs, y or f of x here. That's normal in algebra. We might have something like this. This is a line segment and another line segment. And so it's predictable what's happening in between here. We don't, f of 1 is 1 and f of 4 is 3, but we can tell what the ones in between here are. This is predictable if that's actually a straight line. We could actually calculate the others in there if we got into the slope and stuff of it. There is a change right here, so it kind of goes in two pieces. It wouldn't be a real simple rule, but there's a rule that tells you exactly what f of any of these numbers is. It just goes from 1 to 5, and that's all. But this is a function because each input has exactly one output. So when we talk about vertical line test, we're saying for each input down here, maybe this one's 2.2, any input that you pick, if you draw a vertical line from there, there should be exactly 1 point on the graph. That is exactly one output that goes with that input. So the vertical line tests whether or not it is a function, and this one is a function. Now I'm going to go back through these and think about domain and wrap up this video, but the domain of this function is the set of inputs that make sense. This graph only goes from here to here, from here to here. I don't have an f of 6, I don't have f of 11 or f of -3, right? There's nothing there. So the inputs, the only inputs that make sense in this are the ones between 1 and 5. So it would be some kind of interval of real numbers. The square brackets meaning including the numbers 1 and 5, but everything in between there. And that stands for this interval on the number line. If I shaded it in, it would look like that. And generally, when you have a function like this, either the domain will be the whole number line, or it'll be some interval or intervals similar to this one. Maybe there'd be holes in it, so it's broken up into intervals. There's some variety there, but they're on the number line, and they can be written in interval form from this to that. And that's the form we're looking for. So something like this is only going to result in a real number if the thing inside of the radical is positive. So in order for this to end up as a real number, and it's only going to, we're only looking at this as a function of real numbers. So we need 1 minus x squared to be bigger than or equal to 0. So we need x squared to be less than or equal to 1. This happens when x is between -1 and 1. So the interval would look like this. If for any of those numbers, when I square x, I'm getting something small. So 1 minus that would still be positive, and that'll work. At these points, I get 0. Square root of 0 is 0. That's fine. So those numbers are included, but nothing outside that. And if I get beyond 1 in either direction, that's going to come out as a non-real number. So when we're considering just the real numbers, that's the domain of this one. Now for these, going back to these individual objects, the domain is the set of inputs that make sense. For these things, it's just a discrete set. It's just a set of elements. You wouldn't have an interval here because there's nothing between these. The domain would just be written out as a set with a listing, or you could write it as a rule maybe, but you're going to have to talk about individual elements in here. So typically these are just lists. Those are the only elements that make sense that we can talk about in that. This one's not a function, but it still has a domain. It still has a set of inputs that make sense. if I extended if there was more stuff in here, I could have more elements, but they're individual elements thought of this way. This one is a function, and the input is any word. This would work with any word, so the domain could be the set of words in the dictionary. It's funny to use a variable for them when we're not talking about numerical values, but the set of x such that x is a word in the dictionary. We could make the domain that whole set. So I'm not going to list them all, of course, but it's a certain set of elements that we're talking about there that make sense as inputs into that function. All right, that's enough for now. That's kind of an intro, and you'll see this stuff in the Zybooks work. So I just wanted to make these videos pretty brief, hopefully helpful. I'll talk to you again later on.